Welcome, ladies and gentlemen. So what I'd like to do is show you how to evaluate for our 6 trigonometric functions using an angle. Given here we have theta is 5 pi over 3, as well as theta equals negative 2 pi over 3. And what we're going to do is we're going to evaluate our 6 trigonometric functions. We're going to determine where those angles are going to intercept at our unit circle and use the points that they intercept to evaluate for our 6 trigonometric functions. So the first thing we want to do is see, well, what exactly then is the unit circle going to look at, or what points, can we use? How are we going to figure out those points? So hopefully you have the unit circle memorized, hopefully. But if not, let's just I'm going to try to go through this a little bit quickly to make sure we can design it here. So I just have a blank here unit circle, and I'm not going to do the whole with all the angles, because the only angles we're focused on, and that's why I did this video, is ones where they're broken up into thirds. So that's a bad third. Now remember, if you're thinking about this as like the x and the y-axis and so forth, but if you're going to break these up into thirds here, we could have this. Now remember, here is always what we call, actually, let me use a different color, blue, because we really don't need all this stuff. But just remember, this is what we call our initial side, right? And our initial side has to start on the positive portion of the x-axis. All right, now if I was going to break this up into thirds, I say, well, why are you breaking up into thirds here? Well, remember, if this is the start, halfway around is pi, which would be like 1 whole pi, right? So what I'm going to do is I'm breaking up that distance into 3 different parts. All right, so we really don't need the y-axis right there. We can just kind of leave that there. Now, the reason why I only am dealing with the thirds here, and again, I chose breaking up into thirds because that is the denominator. If you had angles with a different denominator, that's how many sections you would break up the top and the bottom half of your circle. Now, let's go ahead and take a look at our angles here. And so the first angle, when you go up to there, is going to be at 1/2 comma square root of 3 over 2. Now, I'm not going to go over the reasonings of how I get these angles. Basically, ladies and gentlemen, these are coming from your unit circle as well as your right triangle trigonometry, or your special triangle trigonometry. So then, therefore, this is negative 1/2 square root of 3 over 2. OK, cool. So those are going to be our 2 points where these 2 angles intercept. Now, we go and take a look at our first angle, and we see we have 5 pi over 3. Well, this would be 1 pi over 3. This would be 2 pi over 3. And this would be 3 pi over 3, or just pi. So I need to continue, right? So therefore, I'm going to break this up into thirds here. And I'm just going to erase this just so it doesn't confuse me. It's still there. I just don't want it to confuse me. Now, to find these points, all I simply can do is just take these points and reflect them over the x-axis. So the x value is still going to be negative. But now my y value, instead of being positive, is now going to be negative. And then over here, my x value is still going to be positive. But again, my y value is going to be negative. OK, so let's go and start again. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. OK, so now you can see that my point here is 1/2 comma square root of 3 divided by 2. Now, again, when we're evaluating for the sine, cosine, tangent, cosecant, secant, and cotangent, it's going to be very important, especially when we're using the unit circle, to know our x and our y coordinates. All right. The reason why is because to evaluate for the sine of 5 pi over 3, or the sine of any angle or any point that's on any angle that intercepts our unit circle, we can use the y coordinate of where that graph or where that angle intercepts the intercepts the unit circle. So for y, the y coordinate here is just going to be the square root of 3 over 2. So really no math involved. That is, choose y. For cosine, that's going to be the x coordinate. So cosine of 5 pi over 3 is going to be x coordinate. Oops, that's a negative. Did I make that one there? Yeah, OK. That's negative. Make sure it's visible. OK, so the cosine, though, is going to be a positive 1/2. For the tangent, that is going to be y over x. So I have 5 pi over 3. That's going to be y over x, which is negative square root of 3 over 2 divided by 1/2. Well, in this case here, you can multiply by the reciprocal of your denominator, which would be 2 over 1 on the bottom and the top. Or you can just delete out the 2's. And what we end up with is a negative square root of 3 over 1, which is just negative square root of 3. All right, so we did sine, cosine, tangent. Now let's go and get into the reciprocal properties. So the first one is cosecant of 5 pi over 3. And the reason why I'm calling them reciprocal properties is because we're evaluating for the reciprocal. Instead of evaluating sine for y, the cosecant is the reciprocal. So now we're going to evaluate of 1 over y. So that's going to be 1 over the square root of 3 over 2. Again, what you're going to want to do is multiply by the reciprocal on the top and the bottom. And therefore, you're left with 2 over the square root of 3, which then again, you need to rationalize the denominator. And your final answer is 2 square root of 3 over 3. To determine the cosi or the secant, let's do 5 pi over 3. So the secant is going to be 1 over x, which in this case is 1/2. So I do 1 over 1/2. Again, multiplied by the reciprocal. And that's just going to leave me with 2. And then the last one is cotangent. Well, so where tangent was y over x, cotangent is going to be x over y. So I simply just take 5 pi over 3. And cotangent is going to be x, which is going to be 1/2 divided by negative square root. Oh, that's a negative. I forgot. That's a negative. So therefore, when I multiply, that's still negative going on. So that's a negative answer. Negative square root of 3 divided by 2. Again, the 2's you can divide out, and therefore I'm left with 1 over negative square root of 3. Again, I still have to rationalize my denominator, so I have to multiply by the square root of 3 over the square root of 3. And my final answer is going to be a negative square root of 3 over 3. OK. Whew. These ones, man, they get a lot of students. They take a little while. So anyways, all right, let's go to the next angle then. So we completed our 6 trigonometric functions. So now let's go to the next angle, which is negative 2 pi over 3. Well, in our first angle, we went in the positive direction. So now we're going in the negative direction. And in the negative direction, we go negative 1 pi over 3, negative 2 pi over 3. So we're going to remain still again in the lower quadrant, but now it's going to be, in the third quadrant, and we have a different point, where now x is negative 1/2, and y is going to be negative square root of 3 over 2. All right, so again, the main important thing, though, is identifying what is your x and your y. So in this case, we have our x and we have our y. So now let's do the sine of negative 2 pi over 3. Again, sine just represents the y coordinate, right? So we look at the y coordinate and we say, all right, negative square root of 3 over 2. Done. Cosine. Aha. No, 1 minute. The cosine is going to be your x coordinate, which is going to be negative 2 pi over 3, is going to equal to negative 1/2. To determine the tangent, again, that's going to be our y over x. So I'll simply just take negative square root of 3 over 2 divided by 1/2, which you notice is the exact same as this one, except they're both negative. Well, since they're both negative, that's going to make it positive. So I'm going to take my exact same answer and just rewrite it as positive. For the cosecant of 5 pi over 3, that's going to be 1 over y, which is, again, the same thing as this point. And actually, that's negative as well. So I'm going to have my exact same answer, which would be negative 2 times the square root of 3 divided by 3. Then I have secant of 5 pi over 3. Secant of 5 pi over 3 is going to be 1 over x, which in this case is going to look just like this one, except now my x is negative. So therefore, my answer is just going to be a negative 2. And then finally, last but not least, I have cotangent, which is going to be x over y. So again, it's negative 1/2 over negative square root of 3 over 2, which is very similar to this one, except the 1/2 just needs to be negative. So my answer is just going to be this answer, but positive. Why am I writing 5 pi over 3? That should be a negative 2, negative 2. So therefore, my final answer would be square root of 3 divided by 3. So there you go, ladies and gentlemen. That is how you evaluate your 6 trigonometric functions for an angle when your denominator is 3. Thanks.